All right, let's just jump right into this explainer. Today, we're talking about how to strictly apply digital color theory to literally knock your SDXL and Midjourney personal style files out of the park. Look, if you've spent any time at all generating AI images, you already know that color is the absolute make or break factor, right? Nailing the tones creates raw emotion and striking realism. But if you get it wrong, yeah, it can instantly ruin an otherwise fantastic concept. I mean, we've all been there. You know that super frustrating feeling of finally getting an image back from the generator and the skin tones are just way too orange, or the shadows are bleeding this weird neon blue. It's that ubiquitous artificial AI glow. It just looks kind of plastic. It completely lacks the depth and subtlety of a real photograph or a masterfully painted canvas. Well, today we're gonna fix that. We're gonna stop treating color like some random roll of the dice and start using it like a precise, director-level tool. So here's our roadmap. We'll start with the AI glow problem, then look at how machines actually see color. From there, we'll cover teaching AI human taste, the absolute magic of negative prompts, advanced palette guidance, and finally, wrap it up with your own actionable color control workflow. Okay, section 1, the AI glow problem. Let's dig into the root of that overly glossy artificial aesthetic. A lot of this headache actually comes down to what professionals call the HDR trap. Think about it. When you drop words like vibrant or dramatic or dreamy too early into your prompt, the AI takes those instructions extremely literally. It just cranks up the saturation, blasts the contrast, and falls right into this trap of over-processing the whole thing. And the results? Visual detail just collapses, literally collapses, especially in the midtones, which, by the way, is exactly where realism lives. That's what leaves you with those overly glossy, glowing images that completely shatter any illusion of reality. Moving on to section 2, how machines see color. What's absolutely fascinating here is realizing that AI just doesn't see color the way we do. Let's look at the science. See, we intuitively understand color as emotion, right? Like we just feel that a muted teal is calming, or we know instantly that a harsh magenta is going to clash with a really soft scene. But AI interprets color conceptually. It's basically looking at thousands of images linked to specific words and just guessing. It's guessing the energy of a color based entirely on mathematical patterns and associated tags. It doesn't inherently get color harmony. It only understands pixel proximity and statistical likelihood. And because of that pattern-based approach, every single AI model out there has its own built-in bias. It's basically an internal default color tendency. For instance, Midjourney naturally leans really heavy into contrast and highly vibrant palettes. Stable Diffusion, on the flip side, often leans toward cooler or more neutral tones, but honestly, it can sometimes lack color depth. Understanding this is absolutely crucial, because it means we have to actively intervene to control the final output. We can't just sit back and let the machine default to its own habits. So, to achieve really precise color differentiation without confusing the model, computer vision often relies on alternative color spaces beyond our standard RGB. One highly effective model is the HSV color space. That stands for hue, saturation, and value. And what makes HSV such a game changer is that it wasn't just built for pure math. It was actually designed specifically around human psychology. It separates the actual color, or the hue, from its purity and its brightness. This mimics how you and I actually perceive light and shadow out in the real world. And to put that into perspective, this perfectly illustrates another really advanced application. Here, researchers compared RGB prediction to the CILAB color space. Notice how the lightness, the L, is completely separated from the A and B color channels. By isolating lightness in the actual architecture, the model only has to predict the hues based on a distinct brightness channel. In practice, this results in beautifully contained, ultra-precise coloring. It completely eliminates those uneven, muddy color splotches we've all seen when using standard RGB processing. All right, section 3, teaching AI human taste. Because the AI doesn't have this inherent understanding, we really have to step up and play the role of the cinematographer. Which means you've got to stop just listing random colors and start defining actual relationships. Instead of just typing in a blue wall and an orange shirt, you need to establish true color harmony by giving the AI explicit frameworks. Try prompting something like complementary palette of teal and orange cinematic tone. See, that acts as a visual compass. It forces the AI to choose hues that actually harmonize and complement each other rather than fighting for the viewer's attention. Another fantastic way to teach the machine our human taste is by integrating real-world photography terminology.
Seriously, when you drop in cues like shot on 50mm lens, soft key light, or balanced white balance, you are handing the model a highly specific lighting blueprint. And remember, color literally does not exist without light. By controlling the exposure with phrases like realistic dynamic range, you fix those underlying exposure issues that cause washed-out highlights or super muddy shadows. It basically guarantees your color sits perfectly within a believable, realistic environment.
Okay, let's jump to section 4, the magic of negative prompts. This is all about the rule of restraint, and it's our ultimate defense against bad color. Welcome to the colorist's safety net. You see, using negative prompts isn't just about removing an unwanted object from a scene, it actually fundamentally alters how the AI calculates color. By actively forbidding things, like typing in no orange cast, no oversaturation, or avoid HDR lighting, you are literally forcing the AI to naturally rebalance the midtones. It acts like a tone limiter. It prevents color contamination and that dreadful artificial bloom before the image is even rendered. Trust me, it's an absolute game changer for getting that mature professional aesthetic. Which brings us to section 5, advanced palette guidance. If your goal is knocking your custom SDXL personal style files out of the park, you absolutely need to know about this cutting-edge approach. So you might have tried simply typing raw hex codes or specific RGB numbers right into your prompt, right? Only to find the AI either totally ignores them or hallucinates some really weird artifacts. Well, this happens because standard clip text encoders, which are basically the language brains of these image models, are built to understand semantic concepts. They are not built to read explicit mathematical color values. They just aren't equipped to translate raw data numbers into visual harmony. But to solve this language bottleneck, researchers are now developing these absolutely fascinating new architectures that use separate dedicated palette encoders. So instead of trying to force a color description through a text encoder, a specific color palette is encoded and fused directly with the text embeddings right inside the latent diffusion model. It's brilliant. This completely bypasses those language limitations and forces strict mathematical color harmony onto the generated output, completely independent of whatever your text prompt says. And the results? They are incredibly promising. When researchers evaluated generated images against reference palettes, incorporating actual palette embeddings just drastically outperforms standard text-driven colorization. Just notice how closely the output on the right matches the input palettes compared to the baselines on the left. When you need an exact aesthetic match, say for a cohesive brand identity or a highly specific cinematic look, this multimodal conditioning is 100% the future of AI color control. Now, how do we actually take all this high-level theory and use it every single day? That leads us to our final part, Section 6, your color control workflow. Let's bring this theory home and build your actionable daily workflow. If you want unparalleled consistency, I highly recommend following this strict 4-step process. Step 1, start neutral. Generate your initial test images using terms like balanced daylight. This helps you avoid any baked-in color biases. Step 2, define your intention. Call out a specific harmony, like a muted cool palette. Step 3, apply your negatives. This is your safety net to crush any HDR glow or oversaturation. And finally, step 4, lock your palette using real-world references, like Kodak Portrait Tone. And crucially, remember to stick to one AI model for a specific project so you keep your color fingerprint perfectly consistent across all your generations. At the end of the day, color is emotion, and emotion is storytelling. By mastering these digital color theory techniques, everything from lighting cues down to dedicated palette encoders, you can finally stop letting the machine guess. So here's the real question. Are you ready to take control, apply this theory, and finally knock your SDXL personal style files completely out of the park? Thanks for hanging out with me on this explainer, and I'll catch you in the next one.